Alright, this is chapter 2, homework assignment number 1. Start with 2-7. In 2-7, Ben is taking math class and he's stuck on this problem. So here's the problem. And then you're supposed to examine what he's done so far and then show him how to do the answer. So here's what he did first. He saw that it's parentheses raised to the third power, so he repeats it 3 times. And that's perfect, because the next step after that is we have the coefficients, the big numbers in front, 3 times 3 times 3. Remember, these are all multiplying. And then we have the A base items, that's A times A times A. Each of those is raised to the power of -2. So I'll circle those. And then we have B's, we have 3 B's. And remember, when there's no exponent, it's actually still raised to the power 1. Alright, 3 times 3 times 3 is 27. A. What happens there is when you multiply 2 numbers or values with the same base, their exponents add. So it just becomes a single A, base A, and then all these -2's add together. And then the same for the B's. Alright, so that is going to be 27A to the power of -6, -2, -2, -2. If you add those, that makes -6. And then B to the power 3. Now there is actually one more step. You can't have negative exponents. That is a problem. So what you do is you make a fraction. 27B cubed, and what you do is you cross the line, change the little sign. So here's the little sign, that changes. Cross the line, change the little sign. There's your answer. Alright, 2-8. This is a graph function, h of x. We should estimate the values below. They don't have to be exact, but they should be close. It's kind of hard to tell because the graph is blurry. So A is h of 1. So the input is 1. The inputs go in on the x-axis. So that tells you to find 1 on the x-axis. And if you go up, you're going up about 2 units. C, x when h of x equals 0. What is x? Hint, there are 5. Alright, this one's different. There's no input given. Instead, we're actually given the output. So if you're given the output, you need to look in the output axis. Find the number is 0, so find the number on the output axis, 0. And then you see, where does it hit on the x-axis? And it actually hits in 5 places. So I gave you a little hint there. So our graph hits 0 in 5 places. So that's going to be -5. This one looks like -2, 0. This one's probably 2. And then that looks like 4. Alright, next we have the normal input one. We have an input of -4. So if you come to -4 on the x-axis, it's the input axis, and then you go up, how tall is the graph here? Well, the output looks like, I would say 13. You can do the rest of them. Please do them all. Remember, I'm just doing half of the problems. Okay, 2-19. Which one has no solution? So if you're looking at A, the way you would solve this is you would distribute the 4. Might remember this from middle school. 4 times x is 4x. And then there's a plus sign. 4 times 1, which is just 4. And that's equal to 2x plus 4. So let's go ahead and solve this. Take away 4 on both sides. Those both make 0 pairs. Let me make a little table. So we're just going to have 4x and 2x. Now, if you're thinking about tiles, think about it like this. We've got 2x tiles on the left, and we've got 4x tiles on the right. So what we can do is remove the same amount of tiles from each side. Remove the same amount of tiles from each side. And so on the right-hand side, there'd be nothing left. 0. On the left-hand side, we'd still have 2x. Alright, last step. So here's what we have. This is where we're currently at. 2x equals 0. If you divide both sides by 2, x is equal to 0. 0 divided by anything is still 0. All right, you can try B. It says which one has no solution. So make sure you solve B and then verify that no solution exists. Let's try 2-20. I'll do A, I'll do D. So for A, we're just supposed to evaluate. That means plug in 1 minus 2, 1 minus 2, and then 2 times negative 2. Plus 3 times y, and y is negative 5. So those are the numbers that get plugged in for x and y. Let's simplify. Negative 2 multiplied by negative 2 is actually plus 4. So this becomes just plus 4. And then over here we have 3 times negative 5, and a positive times a negative stays negative. So it's 1 plus 4, which is 5. And then since we're adding on a negative number, that's actually the same as subtracting. So this becomes 5, and 5 plus negative 15, or 5 minus 15 is negative 10. Let's try D. D, this one has fractions, a little tricky. So 1/2 times x, where we'll replace x with the number 2, plus 1/3 times y, where we're going to put in 5 for y. And then let's see what happens. Well, 1/2 times 2, you can kind of think of 2 as 2 over 1. So you have 1 times 2, which is 2, over 2 times 1, which is 2, plus, same deal over here. When you have a whole number, you put it over 1, and then you multiply straight across. So that's going to be 5 over 3 times 1, that's 3. All right. Now, if you notice 2 divided by 2, or any number divided by itself, that's just 1. So we have a problem now. We can't add fractions unless they have a common denominator. So what we need to do to this is make it have a denominator of 3. Since it's 1, it's got to be 3 divided by 3, right? 3 divided by 3 is 1. So you change the 1 to become 3 divided by 3. And now I can add the fractions. They have a common denominator. 3 plus 5 is 8. 8 all over 3. Remember, when adding fractions, you don't add the bottom. You just add the tops. So that's the answer. You could write it as a mixed fraction, which is 2 2/3. Or you could even write it as a repeating decimal. 2.6 repeating. All right, 221. Calculate the output for the function with the given input. If there is no possible output for the given input, explain why not. That's the important part. You need to explain on this one. So f of 1 equals, this is our function. So x gets replaced by the number 1. 1 over, instead of x minus 1, it's going to be 1 minus 1. So there's actually no output. Do you remember why? I'll leave you to explain it. Check your notes or packet. We did this one before. But make sure you have an explanation there. 2-32. Try A. So A, we're multiplying numbers, and the answer needs to be in scientific notation. Okay, so I'm going to rearrange a little bit. This is 6 times 4. We'll multiply these two numbers. And then we'll multiply the powers of 10. So that's 10 squared times 10 to the power 5. Okay, 6 times 4 makes 24. And then remember, when you're multiplying two numbers that have the same base, the exponents are going to add. So it's 24 times 10 to the power 7. Now there's a problem. In scientific notation, this number has to be between 1 and 10. But that number is not between 1 and 10. So here's what I'm going to do. I'm going to expand it out. The decimal's here, so I'll move the decimal over 7 times. 1, 2, 3, 4, 5, 6, 7. So it's 2, 4, 1, 2, 3, 4, 5, 6, 7. So I move that decimal over 1, 2, 3, 4, 5. Yep, 7 times. And then I'll bring it back in. But when I bring it back in, I'm going to move the decimal here. 1, 2, 3, 4, 5, 6, 7, 8. Now, 2.4 is between 1 and 10. And we move the decimal place 8 times. So that's 10 to the power 8. Okay, let's try B. B is kind of the same situation. You multiply the numbers in front, 1.75 times 8, and then you multiply the powers of 10. Okay, when you multiply these guys together, you're going to get 14 in your calculators, or you can do that one in your head. And then again, when you multiply tens, the exponents add. These have the same base. And when you have the same base, let's add the exponents. Okay, so this is what I have. 14 times 10 to the power negative 10. So now what I'm going to do is move the decimal. Since it's negative, that means I need to move the decimal left 10 times. So that's going to be we're going to have 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 4. That would make 10 movements of the decimal place from here all the way down to there. Okay, now, because 14 wasn't between 1 and 10, I had to do that. So now I'm going to move it back 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. So it's going to be 1.4 times 10 to the power negative 9. So you can see the problem with these two was really similar. The exponent was just off by 1, and then you make this number in between 1 and 10. Okay, so I'll let you try C. Let's move on to 2-6. 2-6, it says there are 5 tiles in figure 0. That's important. And it also says we're adding 7 tiles in each new figure. So what we call figure 0 is the starting value. And the starting value is 5. And then over here we have what we call the growth. And the growth in this situation is going to be 7. So this is our equation, y equals mx plus b. And we replace m with this number. We replace b with that number, and then we just leave in y and x. So it's going to be, y, leave in y, equals, instead of m, I'm going to write 7x, 7 times x, plus the starting value of 5. And that's how you write an equation. I actually did that whole one, so that one is finished. Okay, 2-18, remember slope. Slope is going to be equal to the change in y divided by the change in x. And so the way you do that is they mark the 2 points on the line for you. You draw a slope triangle, right? You draw a slope triangle, and then this is delta y, this is delta x. So if you're looking, this is actually 6, and then it comes down here to negative 6. Delta x is actually going to be equal to 12. This is a distance of 12. And then delta y right here looks like it goes up to 4. So delta y is equal to 4. So I'll let you do the final calculation, plug those numbers in, and what is the slope? All right, Yoshi is graphing lines, 2x plus 3, 2x minus 2. So I'll use the same color. The starting value here is plus 3. Those are the starting values. So that tells you where to look on the y-axis. So here you can see this is 0, 1, 2, 3. There's the line that has a starting value of 3. And then here's the line that has a starting value of negative 2, because it's 0, negative 1, negative 2. Okay. For part A, oh, let me point out the growth too. The growth is the same. Same growth. All right. So part A says we're supposed to match the equation. Which one goes to 2x plus 3? Well, as I kind of mentioned, that's got to be this one. Has a starting value, or the official word is y-intercept of 3. So that means that goes with that line. And then y equals 2x minus 2. What that has is a starting value, or y-intercept of negative 2. So what you do is you find the line that has a starting value, or y-intercept of negative 2, and that's got to be this one. So this line has the negative 2 starting value. That one has the plus 3. All right, Yoshi wants to add this line to the graph. So what you do is you analyze the starting value, plus 1, and then that tells you where to go on the y-axis. So if you go to 1 on the y-axis, that's where the starting value is going to go for this new equation. All right, and then if you notice, the growth is actually the same. So that means the line's going to be growing at the same rate. It's going to have the same slant, which means that it's going to be parallel. So it looks something like that. So it has a starting value or y-intercept of 1. And that's why we put the point at 1 on the y-axis. And then the growth matches the other lines. The growth is the same as the other lines. So they will all be parallel. Or you can say, so they all slope the same direction. In the same direction. Since they're all growing the same, they're all going the same way. All right, and you can work on part C. Let's check out 233. All right, 233a. Step 1, rearrange so that the coefficients, or these big numbers, are at the front. 5 times negative 3 times, we still have x raised to the power 3 times, we still have x to the power negative 2. Okay, and 5 times negative 3, positive times negative is negative 15. And that's going to be multiplied by x to the power 3 plus negative 2. These two numbers, they have the same base, and when they have the same base, you're allowed to add the exponents. Okay, so that's going to be negative 15x to the power 1. And because it's to the power 1, you make the 1 invisible, and you write it like that. I'll do C, you can do B. If you need help on B, just kind of watch the video for 2-7. I solved that one for you. It's really similar to 2-7. So go back to 2-7 for B. I'll put C 2-7. And then for C, what you do here is you have 3m. And notice that these m's have the same base. So what you do is you subtract the exponents. When two things have the same base, the exponents subtract. So it's going to be 3m to the power 7 minus negative 1. Be careful, it's 7 minus negative 1. So that is actually 7 plus 1. And so this turns into 3m to the power 8. All right. Which of the graphs below have a domain of all real numbers? If you look at A, the domain goes left to right. So because there's an arrow on the left and an arrow going right, this graph is going to have a domain of all real numbers. Okay, let's look at B. B, remember domain is left to right. And because B has an arrow coming out to the left and an arrow coming out to the right, the domain is going to go on forever, and it's going to be all real numbers. All right, when you're looking at C, the domain for this, now we do have an arrow going to the right. We actually have 2 arrows, so it's going to go to infinity, except if you check out the left-hand side, there's like a wall right here. It never goes past this point. So it never goes past negative 2. So the domain is actually negative 2 to infinity. That means I don't need to write anything, because it just says which ones have a domain of all real numbers. So C is out. I'll let you work on the range. Kind of the same idea, but remember range is top to bottom. And then make sure you read the question, because there's one more. It says functions. So don't forget to write about function. And I'll let you answer those. So you're answering for all these. Is it a function? Yes or no? 2-42, scientific notation. And this is going to be our last one tonight. So 4.51 times 10 to the power negative 2. This is a power of 10. Check. This number is between 1 and 10. Check. So the answer is yes. We don't need to do anything. How about B? B. This thing is a power of 10. So that's a check. This thing, is it between 1 and 10? No, it's not. So what that means for B is that we need to rewrite this. So I'll erase this stuff and let's get to work. Alright, when you have 10 to the power 5, that means move the decimal place to the right 5 times. So it's 7, 8, 9, plus 2 empty spaces which get filled in by zeros. That's 1, 2, 3, 4, 5. Good. Then we need to make this number in between 1 to 10. That was the problem. So if I move the decimal right before the 7, I'm good to go. Because now it's 7.89 times 10 to the power 1, 2, 3, 4. 10 to the power 4. Now I could write 7.8900, but those zeros aren't really necessary because 7.8900, that's just the same as 7.89. Those zeros on the right hand side don't do anything when you have a decimal point. Alright, you can try C and D. There's one good one and one bad one. That's it for tonight.